Welcome in part 2 of the Take a Break series that I think will be in 3 parts. This time I'm gonna weld up and recut these tapers and also recut the thread here on this side. I have to build up 12 millimeters in height, so that's a lot. It looks a bit like a pile of pancakes, but the height is there, so I'm gonna let it cool down and then over to the lathe. I use this little tool normally for aluminium because it gives way less cutting forces than the other one. So I'm gonna take it easy because there's a lot of stick out here. Before I drill the center, I just check to see if the thing is still centered, and it isn't. A run out of 1/10 of a millimeter, that's not much, but we can do better. One hundredth of run out. I think that's good. Not too bad. I left it a little bit oversized. Now I see here that I have to build up a little bit more material in here. And that's why in last week's video I made these rollers. It will make it really easy to position my workpiece here. And of course not forget the round clamp. But before I start welding, first I'm gonna give it a little bit of preheat. And sometimes in comments people ask, why preheat for welding? This thing should be hot enough, right? It is. But imagine I want to weld my vise using my camping gas thing here. Of course this doesn't give enough heat to weld it, but it's just an example. Now this thing is room temperature. So let's start welding. That's it. What do we see? Condensation. And I suppose you understand that molten metal and water doesn't mix very well. So we heat the workpiece hotter than 100 degrees Celsius to make sure there will not be condensation on it. and suddenly my welder stopped welding. And after a little bit of investigation, I think I found out why. No more wire. Ah, here's a new one. Since always, I like more these plastic bobbins than these steel ones. This one looks cool, but at the end of the wire, these little studs here make indents in the wire. And so sometimes the wire gets stuck a little bit and it's not a smooth transition. This one here is nice and perfectly round, and the wire will not get any dents even at the very end. So if you have a choice, choose these bobbins, much better than these, but I had no choice. All welded up and cooled down, and first I will cut it straight at 34 millimeters, of course, and then I will start cutting the taper and then hope that there is enough material everywhere. Maybe this is a bit low. We'll see. The taper seems to be spot on, and the distance here between my bearing and the rim, almost. Just a little touch of sandpaper and it will be good. But first I want to fill up this little pitting here, because as is it would work perfectly fine, but I think it will be better if it's better. I finished round 2 of the welding up operations, and I hope it will clean up completely. I see here now there is a little spot, it's not enough weld on it, but of course I can always weld round 3. I touched off, but this time with a high-speed steel round tool to have hopefully a little bit better finish. Let's normally I have to take one more pass to have it to size. As you can see, it didn't clean up here. But first, let's have some test fit. I already tried, but I forgot to press record on my cam. So now I'm doing it again. And as you can see, It fits. Right, this one can go if it wants to. Damn, that's a good fit. Let's do a quick little cleanup here, and then after I can cut the threads. That will do. Of course, I installed my thread cutting tool, and of course also the right pitch. To pick up on the existing thread, because of course it has to be continue, it's not really that complicated. All you have to do is bring the tool close without engaging it, of course, and then we engage the half nuts. Start the machine and stop it again. So now we're sure there's no play anymore. My cutting tool is now engaged completely in the existing thread, so without forcing, and this is where I will install my zeros. Take the tool out again, of course. From now on I'm only using the top slide to feed in, and here goes the heating system. I'm afraid you will have to learn to live without footage of the thread cutting operations. Of course I installed my camera, but I didn't notice that the memory card was full. So filming without memory, that doesn't work. But the thread is cut and it looks okay-ish. Unfortunately, I don't have a nut to do a test fit. Right, let's do the other one. Done! It was basically 2 times the same operation, so I don't really see the need of showing you 2 times the same. Okay, next step in this little project is making 2 rings. Because this drum is now sitting deeper on the taper than the original one. There is a part here that sticks out. And of course, if I tie a nut here, that's not gonna hold. So I need to fill up the gap with a ring that I have right here. That's not gonna work. I'm using this taper adapter, but it doesn't fit very well in the tailstock. So let's find another solution. This will work. Use the other lathe. That worked. This is of course a lot of workpiece stick out. So to bore it out I will take light cuts and it will work. I installed my maximum depth stop here. Right, let's do this. When the boring bore is here in the beginning, it sounds completely different than it's deep inside. There may be a difference in hardness of this material, I don't know. And the finish could be better. It's not bad, but for a stupid washer, that will do. Good. I don't know if they're gonna use these rings or not, but if needed, they're here. So far so good. All that's left to do now is to cut a keyway in here and of course also make a key here on the milling machine. And of course also cut a keyway here in this brake drums and figure out a way how to hold it here on the shaper. But that will be in next week's video.